All complex robotics projects start with the simple basics, and today I'll give you the core. We will build a cute four-wheel drive platform controlled with a regular PS5 gamepad. You'll learn how to build a clean shield for ESP, how to deal with motor drivers, and how to upload and configure firmware. And the most surprising part, you can set it up without programming skills. It's a perfect start for beginners, minimal complexity, maximum fun. Before we start building, let's quickly go through the list of parts we need. As a base, I took an acrylic kit from AliExpress. Nothing special inside. 4 motors that run from 3 to 6 volts, a frame, a handful of screws, and a battery holder that I decided not to use. Instead of AAA batteries, I prefer using 2S lithium-ion battery. It's rechargeable, and as a bonus it has 5 times more capacity. The only problem, the battery gives 7.4 volts, so I need a buck converter to lower the voltage to 5 volts. The platform will be controlled by ESP32. It has built-in Bluetooth to connect the PlayStation controller, and I also wrote a visual configurator for ESP. With it, we can set up the platform behavior without a single line of code. Unfortunately, ESP doesn't have enough power to drive motors directly. That's why I took 2 drivers. Each of them can control 2 motors at once. For this project, I want to make a simple shield to avoid soldering components permanently. I want to be able to insert and remove them if needed. For this, I'll use 70x40 protoboard and some pin headers. From what's left, I'll use a button and XT60 connector for my battery. You will find the full parts list with links in the video description down below. Let's start with making the ESP shield. First, we need to solder pin headers on the driver and ESP if they are not soldered yet. To make it straight, I'll use a breadboard. And don't forget to solder J1 jumper to simplify driver's control. Then I insert connectors into the protoboard and solder them. First for ESP, then for both drivers. It's important to leave some space near the driver output pins, since motors will be connected there. Next, we need to connect all components together. To make it clear, I drew a simple diagram. The easiest way: first connect the logic pins, yellow lines, and then power. Such approach minimizes the mess and reduces error chances. To see the pin labels, I insert the component and connect everything following the diagram. Before wiring power lines, I connect buck converter. It will be glued with a double-sided tape under the ESP, so I've chosen the wire's length with that in mind. When everything is ready, I place components in place and verify with multimeter that wiring is done correctly. The frame assembly isn't difficult at all. I start from mounting the button. It's a bit bigger than frame holes, so... Then I place it and fix with some glue. Then I solder wires to motors, because after mounting, it will be difficult to do. Each motor is mounted with 2 spacers and long screws. The only one note: don't tighten the nut too much, because the acrylic parts can crack under the pressure. These black parts are for measuring speed and wheel sync. For this you need an extra modulus, but I think we can go without them, since high precision is not needed here. Still, I'll put them just for decoration. After the motors are installed, I can mount the brass standoffs. I won't put the top cover yet, in case I need to deassemble something. It's time to connect the button and place the shield. At this point I realized that it was better to wire button before installation, but it's okay. Once you're done with the button, install the shield using double-sided tape. To connect motors, I go with a clamping tool. Add the connectors and plug the motors. And finally, solder XT60 connector. The platform is ready. The only thing left is to configure it, which is pretty simple. To set up the ESP, we need to flash the firmware. In the video description, I left a link to the latest betaride release. Download the zip archive, open it in VS Code with Platform.io installed, and upload the firmware. If you're not familiar with Platform.io, I left the link to my video which explains the process in details. Now, open the configurator. First, I add 4 motors and select pins according to wiring diagram. I set reverse timeout to 50 milliseconds for faster reverse response, and especially because motors are not powerful at all. All other settings I leave as default. As being said, I'll use a PS5 DualSense controller. I choose it from controller list. To connect it, we need to get a MAC address. Hold PS button plus share for a few seconds and press Scan. You will see the success pop-up when controller will be detected. The MAC address field will be automatically filled. Now I save the configurator. After configurator restarts, I connect again. Turn on the controller in pairing mode and wait few seconds. Now configurator sees button presses, which helps with setting up rules. First, I want to check if all motors works and properly configured. R2 stick will control the throttle for all 4 motors. L2 will control reverse. Save the settings and connect the battery. If a motor spins in the wrong way, just swap it wires or change pins in configurator. To make turns, one side should spin forward, and the other side either stays still or spins backward. To control turning speed, I map this rule for the left joystick, but since it doesn't always stay exactly at 0, I added a zone in the middle. Save config one more time. And now I can finish the assembly, place the wheels, add top cover and fix the battery. That's it. If you faced any problems, encountered a bug, have any questions or ideas, let me know in the comments or reach me out in Discord.